This video is a quick introduction to right triangle trigonometry. And when you see right triangle trigonometry, that means you have to have, obviously, a right triangle. And there are three trigonometric functions that we focus on: sine, cosine, and tangent. So you can see those listed out over here on the left-hand side. And what sine, cosine, and tangent are is their operations. Just like addition is an operation or multiplication is an operation. Sine, cosine, and tangent are all operations that you perform on angles of right triangles, and your calculator has memorized all of these different ratios for every single triangle and for every single angle, depending on the angle measure and the side lengths. So it's pretty cool. So if we look at this right triangle, CAT, right triangle CAT, we can identify the sine, cosine, and tangent based on knowing what your calculator knows. So first things first, sine is the way that we say this operation, but if you look on your calculator, you will see it abbreviated, or we'll abbreviate it in math problems as SIN. We don't pronounce it sin, we're still pronouncing it as sine, but we're always going to be taking the sine of an angle. And same thing, cosine. If again you look at your calculator, you will see it abbreviated as COS, or cos, or cosine of an angle. And last, we have tangent, which is abbreviated as tan, TAN. And again, you're always going to be putting an angle in the parentheses. And we talked about sine, cosine, and tangent being ratios. So every single time, depending on what angle you are looking at, you want to make sure you label your triangle. Just like we do with all of our other problems involving right triangles, we need to figure out a few different key important side lengths. So first things first, we need to pick the angle that we are referring to. The problem will always tell you which angle to refer to. For this problem, we're going to refer to angle C. So I replaced my angle in the parentheses with the letter C that we're referring to. And I'm going to highlight my angle C because that's our reference angle. That's our starting point. So everything we talk about in this problem has to do with angle C. Now, in terms of angle C, we need to label these three different sides: opposite, adjacent, and hypotenuse. Some of these words might sound familiar to you because we've already labeled triangles in that fashion. The first one being hypotenuse. We know the hypotenuse is always going to be the side that is opposite the right angle. So in this case, it doesn't matter what our reference angle is, our hypotenuse will never change. Our hypotenuse is always going to be opposite the right angle, so side CT is going to be our hypotenuse. Or sometimes we might label it just with an H. H for hypotenuse. Another word that might look familiar to you is opposite. So now we do have to go back to that reference angle. If angle C is our reference angle, we want to label the side opposite to angle C. So similarly to how we did the side opposite to the right angle for the hypotenuse, our opposite side is going to be the side opposite of angle C. So side AT is going to be our opposite side, or again, sometimes we might like to label that just with an O for opposite. Which leaves our last side, the adjacent side, which we can pretty much fill out with by process of elimination. If we know the hypotenuse, if we know the opposite side, then therefore side CA, this last side, has to be our adjacent side. Or we might label it as A for adjacent. And the word adjacent just means next to. So this side is next to angle C, so therefore it is our adjacent side. And once we get those labels, we need those labels because it helps us to set up our ratios. Our ratios for sine, cosine, and tangent all have to do with either the opposite, adjacent, or the hypotenuse. Here are our ratios for our trigonometric functions. Sine of any angle is always going to be equal to the ratio of the opposite side over the hypotenuse. Our cosine is always going to be the adjacent side over the hypotenuse. And our tangent is always going to be equal to the opposite side over the adjacent side. So as long as you know which side is opposite, adjacent, and hypotenuse, you already know how to do trigonometry. And there is a little acronym to help us remember these different ratios. And this acronym is SOHCAHTOA. Doesn't really make any sense. It kind of sounds cool. SOHCAHTOA. Sine, S, is the opposite side over the hypotenuse. That's why it's SOH. Ca, cosine, adjacent, over hypotenuse. Ca. Toa is the tangent side is equal to the opposite side over the adjacent side. So if you can remember this acronym, it could very easily help you remember which sides to put in the correct ratios. So typically we're going to actually ask you to find the ratio of the side lengths, and sometimes we'll give you the side lengths, sometimes you'll have to be finding them in this unit. But for today, we're just going to focus on the ratios. So this first part asks us to find the sine, cosine, and tangent of angle C. So angle C is our reference angle. I'm highlighting it here. I'm labeling it as my reference angle. Our first step is always going to be to label our sides in terms of this reference angle. Remember, with the opposite, adjacent, and hypotenuse. AB, which is 6, is opposite of my reference angle. 8 is right next to my reference angle, so that's the adjacent side. And the hypotenuse is the hypotenuse, the side opposite that right angle. So once we know which sides are which, we can very easily fill out these blanks using our acronym SOHCAHTOA. Because sine is the ratio of the opposite side to the hypotenuse. Well, if the opposite side is 6 and the hypotenuse is 10, there is my ratio. We do always want to make sure we simplify. I can divide both the numerator and the denominator by 2 to get 3/5 for my sine of angle C. Cosine, ca, is the relationship between the adjacent side and the hypotenuse. 8 is my adjacent side, 10 is still my hypotenuse. Simplifying again, cosine of angle C is equal to 4/5. And tangent, TOA, the opposite side is 6, the adjacent side is 8. When I simplify my ratio, 6/8 can be simplified to 3/4. And that is trigonometry.